Here's question number 20 from the practice final. It says, in a Harris poll, adults were asked if they are in favor of abolishing the penny. Among the responses, 1,279 answered no, 464 answered yes, 397 had no opinion. If you don't have an opinion about this, you should probably look it up on the web because it's actually kind of an interesting topic. It's estimated by some people's calculations that it costs more to make the penny than it is worth, and they bring up some other issues. They've changed the metal that the penny's made out of. They actually had silver pennies at one point during World War II, I believe it was, and my grandpa showed me this silver penny he had because they were using the copper for bullets. But anyway, I'm obviously too opinionated about it, but anyways, 397 people had no opinion. What is the sample proportion of yes responses, and what notation is used to represent it? So the sample proportion is p hat, right? So p hat would be x over n. So to calculate this, we would have to decide what the x number of successes are. Well, it's saying yes responses, so we would take the 464 and divide it by the sum of all people who responded to the poll, which is 1279, 464, and 397. So I know for sure it can't be A and it can't be C. It's got to be either B or D. And let me just pull up my calculator really fast and do this. All right, so that's a total of 990, which means I'm going to take 464x value and divide by 990. Wait a minute. Hold on. It can't be 990 if I've got 1279 just of the no responses. Let me double check that. I mean, it's 2140. So 2140 is the n value. So x over n gives us our sample proportion, and it would be 21, if we're rounding, 217 thousandths, which is right here. The symbol p hat is used to represent sample proportions. There we are, B. Before I leave this question, I want to ask you, what do you think about abolishing the penny? Should we do it or not? Could you live without all those lucky pennies you find on the ground? My girls love to pick up pennies. I do too. Okay, anyway, a survey of 1,603 randomly selected adults showed that 577 of them have heard of a new electronic reader. The accompanying, and let's say that's like maybe the Kindle, what's that? Something light, paper light, paper white maybe is what it's called. The accompanying technology display results from a test of the claim that 34% of adults have heard of the new electronic reader, use the normal distribution as an approximation to binomial distribution, and assume that we're using a 5% significance level to complete parts A through E. They've actually done the hypothesis test right here, or they've calculated the pieces, and this looks like, I don't know, maybe it's a display from Minitab or StatDisk or something like that. All right, is the test two-tailed, left-tailed, or right-tailed? So this is where we try to determine what the null and the claim are. And so I'm just going to quickly grab the pieces that I need here. Let's see, the claim is that 34% of adults have heard of the new electronic reader. Okay, so we're making a claim, a proportional claim. So we're making a claim about the population proportion, and it is that 34% have heard about it. So we could write that as 34 hundredths. And since it was saying that the claim is that that's how many have heard about it, it's an equality statement, right? And again, this is the claim. Well, the alternative is always the place where it differs. The null is always a place where the equality is contained, and that actually in this case is the claim, because that is where the equality is contained. So the null is this statement right here, symbolically stated. And when that is not true, the logical opposite of it is the population proportion is not 34%. So it's, it's either less than 34% or it's greater than 34%. And that's why we, in this case, call it a two-tail. So this is our alternative statement, stated symbolically. And this would be two tails. And that affects how we work out the rest of the hypothesis test. So let's come over here. So we actually kind of knew this because it said that the critical value was plus or minus 1.96. And they were using two tails there. Either way, it's two-tailed. What is the test statistic? Well, they've already worked out the test statistic. I assume that they've done that all correctly. To 2 decimals, that'll be 1.69. And remember, so the test statistic, we use the positive one, and then we can find the area to the left of that, to the right of that, and then we can just double it. Okay, so that's not an issue for us. If it turns out negative, then we find the area to the left of it and double that. Okay, what is the p-value? They've already worked that out. These are questions from chapter 8 when we were starting to build into the hypothesis testing. What is the null hypothesis and what do you conclude about it? The null hypothesis is that the population proportion is equal to 34%. And that's what we test. So it's we're either gonna fail to reject the null, or we will reject the null. So let's look. Our significance level was 5%. And if the p-value is less than or equal to 5%, then we reject the null. So let's see, our p-value is greater than 5%. That means we're going to fail to reject the null. So in terms of what we conclude about it, we will fail to reject it. And then we'll have to come up with our final conclusion. By the way, none of these things have to stay completely in your memory, because you've got, let's go here, you've got the whole hypothesis testing summarized on one of the statistics review pages that you're allowed to use. So when I say something like the decision criterion that we will reject the null hypothesis if the p-value is less than or equal to the significance level, it's right here to remind you. And in our case, since the p-value was bigger than alpha, we will fail to reject it. And then if you know that you're going to fail to reject it, you want to get your final wording, you come over here, and it said, did the original claim include the equality? Yes, it did for us. Did we fail to reject it? Sure, so we're going to come through this column in this row and say there is not sufficient evidence to warrant rejection of the claim that 34% of the people have heard about this electronic reader, this Kindle whatever, or Nook whatever, or whatever. I think I said whatever 4 times. So I would say fail to reject or fail to reject the null hypothesis because the p-value is less than or equal. No. We fail to reject it because the p-value is greater than. When the p-value is less than, think of the picture. That means that all of the area of the p-value is going to fall within the critical region. And in this case, the critical region split up into 2 pieces, but either way, you can see that it's all going to fall into the one piece, so it'll fall also all into the other piece. What's the final conclusion? Let me go back to that. There is not sufficient evidence to reject the claim. So there's not sufficient evidence to warrant rejection of the claim that 34% of adults have heard of this new reader. What was this one? There is no. There is not. To support the claim? No. There's not evidence to reject it. I do like the flowchart version of this, by the way. So I will take you there really fast. On the formula sheet, they have this stuff summarized again. By the way, they also have how to find the p-values summarized as a flowchart. I'm only looking at approved material here. But they have the final wording here and says, does the original claim contain the condition of equality? Yes, ours did. Did you reject the null? No, we didn't. So there is not sufficient evidence to warrant rejection of the claim. And that's because of the sample data we had. All right, there's a hypothesis test. Not really completely done because the work was here already, but all the thought process was essentially there. All right, when 3,007 adults were surveyed in a poll, 76% said they use the internet. Is it okay for a newspaper reporter to write that 3/4 of all adults use the internet? You know, because it's close to 76, so they're saying 75%. That's what their claim is. Why or why not? Identify the null hypothesis, alternative hypothesis, test statistic. Basically, just do it. Do the work. Okay, so what is our claim here? Let me go ahead and just copy the statement. Okay. It is the claim of this newspaper person that 34%, 3/4 of all adults use the internet. So the claim is going to be written symbolically as the population proportion, the population percentage of adults that use the internet is 75%. Now, since that contains the equality statement, oops, let me get that out of there. That would be the null. And when that is not true, what would be true is it's either going to be less than that or greater than that. So it's not equal. If it's not equal, then our alternative statement, the differing statement, is going to be telling us to use two tails. Two-tail test. What level of significance are we going to use here? Does not seem to be decided upon in here. Which I'm not worried about there. Okay, maybe it'll say it later down here. All right, so I'm looking for this one right here, E, I think. Yep. Check the, when they write these, they like to write them in the same order each time, where they write the null first and then the alternative. Sometimes the claim is the null, sometimes the claim's not. Keep your eye on what the claim is, because that's going to be important for the final wording. But this time it worked out perfect. Okay, the test statistic. The test statistic is determined, and that also doesn't have to be memorized. It's all here, chapter 8. You're doing a proportion, one population. And so we're going to take p hat minus p over square root of pq over n. Now we can do all that, but when we know x and n, we can use the calculator to do this. Let's see if our x value turns out to be nice. And what I mean by that is they did tell us what n is. right? But they didn't tell us what X is. But they said that 76% of that survey said they use the internet. So what is 76% of 3007? If it's a nice integer, I can use the calculator for this. It's not. So I could still do it, but I'd have to be faking, because the algorithm and the calculator is written to be able to take X specifically. I could talk all day about it, but let me just show you. If you have not used this, it's pretty nice. And by the way, if you want to know how to use these, I just go to that appendix page. This is one of those printed pages that you can use. This is the reference page. It only has 2 pages to it. If you print it back to back, it's a one-sheet piece of work. Hypothesis testing. If your testing proportion hits stats test, 1 prop z int. No, they didn't mean to say that. That's actually a typo. That would be true up there. It should be number 5, but it's going to be 1 prop z test is what it should say. So someone had a little typo. So you go stat, over to test, number 5. See how it says 1? So it's a 1 sample proportion using the normal distribution hypothesis test. Hit it. Now, it needs to first of all know what your null hypothesis is, and this is some nice notation. So it's P representing the fact that it's a population proportion sub 0. So it's it's a hybrid, right? It's using, pardon me. It's using a morph of this notation right here and this right here. So it's kind of bringing them together to make this P sub 0. So I think that's cool because it tells you that it's the hypothesis test for proportion. So that would be for us. You can either put in 3/4 or you could have put in 0.75 or 0.75. If you put in 3/4, it knows that. Now, getting back to the x over n, we know n is 3007 because that was the number of adults surveyed. But when we actually try to find out what x is by reversing the percentage, taking the decimal form and multiplying, we got 2,285. With such a large sample size, I bet I could actually go for this and see if it works out still. 2,285. And then what kind of test is it? It's going to be a two-tailed test right there. And calculate. So it says that my test statistic is 1.25. My p-value, this says p, it's not standing for, it's not like this p that stands for population proportion. This is p-value. And you can tell because it's this decimal form right here. It's basically 21%. Under the curve, we'll put 2102. Our sample statistic, the p-hat, is 0.76 if you round it. That's pretty dang close. I am betting, I'm going to just go with this, that it's going to probably let me get that in there. So 1.25 rounded to 2 decimals. Keep in mind, everything I'm doing could be done right here, It is not too hard to do that. The p-value, I would do that normal CDF, and I would go from 1.25, and since this is right of center, I go 1.25 up to some extreme value like 9,999. And then it would give me this p-value. Now that p-value is pretty big, so it depends on what we were going to use for the level of significance, and I said already when I was looking at this that they didn't give me a level of significance, did they? But then here it comes. Identify the conclusion that we'd make if we used a 5% level of significance. P-value is not less than the level of significance alpha. And so for sure, even like, because remember at first you would have found half of it and then you had to double it. Even if we were only looking at half of this, it would be greater than half of the 5%. So we will fail to reject the null. So we will fail to reject the null. And then it just depended on whether or not the null was the claim or wasn't. Since the null was the claim, there is not sufficient evidence to reject it. And that is not the same as saying that we just supported this newspaper writer's claim. We didn't support it. In fact, really careful thing we have to do here. We're down here. So read up here. This is the only case in which the original claim is rejected. This is the only case in which the original claim is supported. If the original claim does not contain the equality and then we reject the null, we then actually are supporting the claim. But in this case, we're not supporting the claim, we're just not rejecting it. And there is an important difference. All right, that's number 22. So I think that's 3 questions. Did we do 3? Yeah. Let's check the time here. All right, the next one is going to start taking us to a different distribution. We're not going to use normal distribution, so I'm going to go ahead and stop there. I think I will take the time to do one more thing. This will allow me to show you also how to use StatCrunch instead of the calculator, or remind you. And the nice thing about it is we'll also see how close that was, because remember in the calculator we were faking what x was. We multiplied 76% times 3007 and it wasn't exactly an integer. Okay, so I would go z statistics, 1 sample, and with summary. My sample mean, oh, I'm sorry, stat proportion, 1 sample with summary. Okay, my number of successes, I still don't have. I can still fake it here to 2285. I don't know if it lets me put in decimals. Numbers of observations, 3007. And we're going to do a hypothesis test where we're assuming that the null is 75% and the alternative is not equal to 75%. Let's run it. Yeah, even here you'd have to. So this problem, if it doesn't give me credit for it, it means this problem has to be done by hand. Which again, not too bad. You've got the test statistic calculation here, you got z, and then you just do normal CDF from that. Since it ended up being over to the right, you go from that to like negative to like positive 1 billion, and it'll give you a number that you double to find the p-value. And that flowchart of what I just said is right there. Okay, I'm kind of eager to find out if those numbers were close enough. So we did 20, 21, 22. Yep, we did it. Good enough of a fake. Didn't even argue.